Hello everybody and welcome to today's lesson on biconditional statements and Venn diagrams. Our objectives for today are: I will know when to use and be able to write a biconditional statement, and I will able to interpret Venn diagrams and use them to represent set relationships such as intersection and union, and I will recognize and use symbols of formal logic. Let's look at this example, and you remember this, that was one of our conditional statements from the last lesson. If yesterday was Sunday, then today is Monday. This is true, I think we all agree. But think about it, if we say, if today is Monday, then yesterday was Sunday. Remember what I just did? I created the converse, I moved around the two statements, but we realize that statement is also true. And that's what we call a biconditional statement. The biconditional statement is true both ways. The conditional statement and the converse are both true. You do remember from the last class, as I said, the converse that we create out of a conditional statement is not always true. But if we find that the conditional and the converse are both true, then we have a biconditional statement. A biconditional statement is usually written in the format hypothesis, if and only if, conclusion. And the if and only if part indicates that it's a biconditional statement. And there's also another way of writing this. We can write it with an if with two f's. In symbolic notation, we write it P and then an arrow pointing in both directions, Q. Let's look at an example. Write the converse of the statement, and if the conditional and the converse are both true, then construct the biconditional statement. And then we're going to translate each statement into symbolic form. The conditional states, if the sides of a triangle are congruent, then the triangle is equilateral. Remember, we mark our hypothesis and our conclusion. For our converse, think about our sneakers that make us move around. We are going to move and switch the hypothesis and the conclusion. So our converse is going to be, if the triangle is equilateral, and I'm going to use some symbols to shorten things up. If the triangle is equilateral, then the sides of the triangle are congruent. And I'm already using some symbols here that we're going to continue to use in geometry further as we move along. Is the conditional true? If the sides of a triangle are congruent, then the triangle is equilateral. Yes, this is indeed true. Now let's think about our converse. If the triangle is equilateral, then the sides of the triangle are congruent, and that is also true. Both statements are true, which means that we can go ahead and create our own biconditional. Our biconditional will state our first hypothesis: the sides of a triangle are congruent if and only if the triangle is equilateral. Now let's write each statement in symbolic form. I'm going to use the letters A and B. So the conditional states A, arrow B, and you really can read this: if A, then B. The converse will flip around the two letters: if B, then A. And the biconditional, we start with A again, but our arrow has two tops, two tips, and is pointing in both directions, and that arrow really has the meaning if and only if. Why don't you pause your video for a minute now and write your own conditional statement that is true and whose converse is also true, and then you write the converse, the biconditional, and all three statements in symbolic notation. What about this one? The conditional states if 2 is equal to x, then x is equal to 2. My hypothesis is 2 is equal to x. My conclusion is x is equal to 2. I'm going to create my converse now by using the conclusion of the conditional, x is equal to 2, and using the hypothesis of the conditional as my conclusion of the converse, 2 is equal to x. What do you think? Both statements are true. And therefore I can now go ahead and create my biconditional statement. 2 is equal to x if and only if x is also equal to 2. Using letters for my statements, I'm going to use the letter C for 2 is equal to x and D for x is equal to 2. The conditional is written in symbolic form like this: if C, then D. The converse we will write if D, then C. And the biconditional goes C if and only if D. Let's go and look at the symbolic notations that we have used so far and a couple of other symbols as well. The arrow to the right stands for if, then. The arrow pointing in both directions stands for if with two F's, which is the same as saying if and only if. And you also remember the squiggly line that we used for not. Now we're going to talk about 3 more symbols. An A, which is missing the middle bar, and that stands for and. I'm writing it with a capital A, so you see the similarity. That one stands for and. And flip that symbol on the head. You see a V, and the V stands for or. And then we have a very important one that is usually used for a conclusion, and that is 3 points above each other in kind of a triangular shape, and this symbol stands for the word therefore. Let's look at an example where we can use all these different symbols of our symbolic notation. We have 4 statements, and those 4 statements also are represented by a letter. P represents a quadrilateral, has 4 sides. Q represents a rhombus, is a quadrilateral. R represents a rhombus, has 4 sides. And S represents a rectangle, is a quadrilateral. A rhombus has 4 sides, so that is R. And a rhombus is a quadrilateral. So for and we use our almost A shaped symbol. A rhombus is a quadrilateral. It's represented by the letter Q. A quadrilateral has 4 sides and a rhombus has 4 sides. Therefore, a rhombus is a quadrilateral. So now we already are connecting several statements together. A quadrilateral has 4 sides. P and I'm going to do this in red. R. Then I'm going to use the symbol for therefore, indicating our conclusion here. Therefore, a rhombus is a quadrilateral, and that is represented by Q. And then we have our last statement. If a rhombus is a quadrilateral or a rectangle is a quadrilateral, then a quadrilateral has 4 sides. So the if and then will be indicated by an arrow. Let's look first at the 2 things that are actually part of our hypothesis. A rhombus is a quadrilateral. In other words, Q or, using our V symbol, a rectangle is a quadrilateral, which is represented by the letter S. And I'm going to put parentheses around these because together they form our hypothesis. See, this is the entire part that's following the if. And a quad has 4 sides is our conclusion in this case. So for the if, then we use just a regular arrow that we already know. Our conclusion, a quad has 4 sides, is represented by the letter P. Very good so far. So now please go on and watch the second video that's part of today's lesson that will be on Venn diagrams.